Hey everybody, welcome back to a new week. We're going to be working on our Bellringer today. And remember, for those of you who are new to our class, this assignment is going to last you all week, so don't submit it until Friday. I will post a video each day showing you how to solve that day's portion of the Bellringer. So like today we have 6 problems to do on this one slide, but then tomorrow we only have 1 problem to do. And then on Friday, you're going to come back to your Monday folder, make sure you've uploaded all of your written work, and then submit it. When you upload your written work, I'm looking to see evidence that you have watched my video. So whether you represent your thinking with pictures, numbers, or words, I'm happy. I do not want to just see typed answers with nothing else. We're going to identify the place value of the underlined digits. Now, one thing that kids get confused about is they look at a problem like this and they tell me the 6 is in the ones place and the 5 is in the thousands place. But I want you to go a step further. I want you to tell me the value of this digit. What is that 6 worth? So this 6 represents a group of 6 ones. It has a value of 6, not 1. So if you tell me that it's in the ones place, you're kind of giving me the impression that you think this 6 represents 1, which is not true. And then my 5, that has a value of 5 groups of 1,000. You could write it that way. Or 5,000. You could also write it using exponents. You could write 5 times 10 to the 3rd power. That would be another fancy way to write it. Okay, so let's go ahead and do our line plot. And the reason I'm skipping to the line plot is because I find that this is the most time consuming of this set of problems, and I kind of like to get it out of the way. Okay, so we have 4 5/10. We can write that in fraction form like this. Once you have it in fraction form, you might immediately think or recognize that 5/10 is equivalent to 1/2. Then we have 2 3/4. 4 2/5, and 12/4. Our 12/4 is a reminder to us that our division or our fraction bar is also a division sign. We can write all fractions like this. 12 divided by 4 just so happens to be equal to 3. So this fraction actually has a value that is a whole number. Next, we need to convert these fractions so that they are like fractions. When something is a like fraction, it means that they have the same common denominator. So we're going to take a look at our denominators, 4, 5, and you could kind of go with the 10 or the 2 here. We need to come up with the least common multiple for all 3 of these numbers. Remember, least common multiple, or LCM, refers to the smallest multiple that your numbers have in common. So let's do 10, 4, and 5. So we're going to skip count by each of these numbers. Usually I tell people to write the first 5 multiples and then compare lists, 4, 8, 12, 16, 20, 5, 10, I think it's going to be 15. Yeah, it's going to be 20. Okay, so 20 is the smallest number that's on all 3 of my lists. The least common multiple for 10, 4, and 5 is 20. That's going to be my common denominator. So now step 2 of my work is to convert each of these mixed numbers to a mixed number that has a denominator of 20. So the whole number portion can stay the same. When we're converting 4.5 to 4 and some number out of 20, that one's easy for me to do in my head. I don't need to do any multiplying because I just know that half of 20 is 10. When I'm trying to figure out what 3/4 is of 20, I've just worked with fractions for so long that I just know that 15 out of 20 is equivalent. And you guys will start to have some of these memorized as well, but for now, remember that when you multiply your numerator and your denominator by the same number, that's how you convert these fractions. So 4 times 5 gives me 20. 3 times 5 gives me 15. Then when I'm working with fifths, I'm going to multiply both my numerator and my denominator by 4 to get 20. So 5 times 4 gives me 20, and 2 times 4 gives me 8. So now these are the values that will go on the line plot. I've got 4 of them to go on my line plot. Let's see. 3, 2 and 8/20, 2 and 15/20, and 4 and 10/20. I need to write them like this in order to get them over to, will I be able to, no. Okay, here we go. So when we make a line plot, this is a visual way to represent data. And here I have a range of values, the smallest of which is a little bit bigger than 2. And the biggest will be 3. So I can put 3 on there and put an X. Oh no, the biggest is actually 4.5, my bad. My bad. Okay, so let's do 2, 3, 4, and 5. Okay, so here's my 3. I've represented that with my X. This X represents one piece of data, which is 3. Then I'm going to mark 4.5, or 4 and 10/20. That goes right here. 1X to represent that one piece of data. 2 and 15/20 will go right about here, because that's 2 and 3/4, or 2 and 15 out of 20. And then 2 and 8/20 will go, that has to go just ever so slightly shy of 2.5, because 2 and 10/20 would be exactly 2.5, and this is just a little bit less. So I put my X right there. Don't forget to put 1X for each piece of data that you have on your list. Okay, moving right along, we're going to convert 6 and 5/6 to an improper fraction. So the way I'm going to do that is I'm going to start with 6 wholes. I'm going to go use my visual model for this. Here's 1 whole, 2 wholes, 3 wholes, 4 wholes, 5, and 6. Now each of these wholes has been divided into 6 equal pieces, and I know that because I'm looking at the denominator I'm going to be using for my next whole, which is going to be my 7th. So if each one of these represents 6/6, or 1 whole, how many 6 is equivalent to 6 wholes? That's going to be 6, 12, 18, 24, 30, and 36. So I have 36 sixths plus 5 sixths. So that's my last ungroup, duplicate. Okay, that's my last whole, and this is not I don't have the whole thing here. I only have 5/6 of it. So I'm going to shade in my 5/6, 1/6, 2/6, 3/6, 4/6, and 5/6. So if I count on from 36, that will give me 37.6, 38.6, 39.6, 46, and then 41.6. So this improper fraction has the same value as this mixed number. Okay, next we're going to find the difference between 21 and 341 thousandths and 7 and 32 thousandths. Notice that in order to keep all of my digits lined up by place value, I needed to add a 0 as a placeholder. So I need to have my thousandths stacked up, my hundredths stacked up, my tenths stacked up, and so on. Then I can just go ahead and subtract. All right, so 1 minus 0 is 1, 4 minus 2 is 2, 3 minus 3 is 0. All right, now I've got some borrowing. 11 minus 7 is 4, and then 1 minus 0. Whoops, oh my gosh. Let's try that again. 1 minus 0 is 1. So the difference between these two numbers is 14 and 21 thousandths, which interestingly, you can also write like this. Interestingly, you can also write it like this, 14 and 21 over 1,000. Okay, this is a volume problem. Now the formula that we use to calculate volume is always the same. We're going to multiply our length times our width times our height. So we're going to multiply 5 times 2 times 8, which I'm going to let you do on your own because that seems kind of easy. Just remember that whatever your product is for the volume, you want to express it in cubic centimeters. Any kind of a measurement problem, you always want to be sure to include that unit of measurement. Okay, one more problem, guys. Stay strong with me here. We're going to do our measurement problem and then be done. Okay, so we're converting milliliters, 916 milliliters, to some number of liters. Okay, so let me think. Milliliters to liters. Which one is smaller and which one is bigger? Milliliters are smaller and liters are bigger. So that would be fly to horse divide, of course. We're going to divide this by 1,000 milliliters in each liter. And in order to divide this, I need to move my decimal point over. Now the decimal point in a whole number is always understood to be right here after the ones place, even if it's not included in the written form. When I'm in a situation where I need to move that decimal point, then of course I go ahead and write it in. Now to make this number divide by 1,000, I'm going to move it to the left 1, 2, 3 spots. And so my quotient, or my answer, will be 916 thousandths of a liter. Not quite, just a little bit less than 1 whole liter. Okay, now we're going to convert 2 cups to some number of fluid ounces. Cups are smaller than ounces. No, cups are bigger than ounces, my bad. Bigger, smaller. Horse to fly, multiply. So I'm going to multiply that times the 8 fluid ounces in each cup, and that will give me 16 fluid ounces.